going to analyze, to study principles that are components of a vector. We said that a vector is an object that has magnitude and direction. For example, look at the vector A. The vector A is this one. You see the arrow clearly. This is the arrow of the vector A. And to analyze the component of a vector, what you have to think is find two vectors in the x direction and in the y direction that the sum of the two vectors is A. The question is like this: find A in a way that something in the x direction, this is x direction, something, a magnitude, maybe this is 5, maybe this angle is theta, maybe this is 3, maybe this is 4. 3 squared plus 4 squared is 5. Okay, let's go to do it like this. Let's say that the length of this is 5, the length of this is 3, and the length of this is 4. So the question about component is find a vector A means find the component of the vector means write the vectors in a way that you say how much exists of the vector in the x direction, how much exists in the y direction. In this case, I can write the vector A like this. The vector A will be 3 units in the I direction, because this I say that is 3, plus 4 units, this I said this is 4, this I said this is 4, 3 units in the x direction, 4 units in the y direction. And the y direction I say j. So 3 units in the x direction, and I put the I, and 4 units in the j direction, in the y direction, and I put the j. So 3i plus 4j is the vector that we are talking if you have 3 units here and 4 units here. Okay, the units can be meter per second, or maybe it can be meters if it's position vector. So the AX, if you remember what I have said about sine and cosine, the sine of theta, remember the sine of theta is AY divided by A, by the magnitude of A, by the 5. In the case that I wrote, the sine of theta is the 4 divided by the 5. So this will give you an equation for AY. AY is the magnitude of A by the sine of theta. Cosine of theta, I can have another relation. Cosine of theta is AX divided by the magnitude of I. In our example, AX is 3, and the magnitude of A is 5. So this gives you an equation that says that AX is magnitude of A by cosine of theta. And these are these two equations. These two equations are written here. Okay. And Pythagoras theorem say that the magnitude of A, they don't write the magnitude of A, but this A is being interpreted like the vector A, his magnitude. Okay, so wherever you have a vector, you can write the vectors like this. You can make example. You can go to conceptual question on vectors, and you can see many practice problems for writing the vector in this way. So the second thing, you see that AX in the x direction plus AY in the j direction is the vector A. In other words, how much of A is on the I direction, on the x direction. This is the guy. How much of x is 3 in this case, ax. How much of a exists in the y direction? And this is ay. And how much is in our case is 4. So the vector will be 3i plus 4j. This can be written, because ax is magnitude of a cosine of theta, can be written in this way. Magnitude of a cosine of theta I plus magnitude of a sine of theta j. And this also can be written like the magnitude of I cosine of theta I plus sine of theta j. And this is the form that we will use many, many times to solve problems. Now we go to the question how we are going to add two vectors. Let's say that I have this vector A. Let's say that this is 3 and this is 4. Oh, I know who is A. And this is B. And now let's say this is 3 and this is 4. Let's say that now this is 4 and this is 3. Okay, no, so now I will write A. A will be 3i plus 4j. 3 meters in the x direction and 4 meters in the y direction. And what will be v? V will be the vector that is 4 meters in the x direction, 3 meters in the y direction. So it will be the vector 4i plus 3j. What is the magnitude of A? Oh, the magnitude of A is here, is Pythagoras theorem, ax squared plus ay squared. This is the equation. The magnitude of A is 5. What is the magnitude of V? Oh, the magnitude of V is also 5. Oh, the magnitude of A is 5, the magnitude of V is 5, but they are two different vectors because they are in different direction. What is the vector A plus B? The vector A plus B is, you see, I have a draw vector V 4i, 3j, 4 and 3. And I have draw, I have sketched this vector 3i, 3 in the x direction, 4 in the j direction. So this is the vector A, 3a. And what is the vector A plus B? The vector A plus B is the vector that goes from here to here. So this vector, the vector A plus B, is clear. The vector A plus V, that is this big vector, this one, is the vector that is 3 and 4. 3 and 4. 7 units to the right, to the x direction, plus here I have 4, here I have 3, plus 7 units in the j direction. So how do we sum vectors? If I have A equal AXI plus AYJ, and I have V equal VXI plus VYJ, who is the vector that represents the sum A plus V? The vector that represents the sum is the vector that have components in the x direction as AX plus VX. You see, AX plus VX in the I direction plus AY plus VY in the J direction. And what I have learned is how to sum vectors. So to sum vectors, we sum components by component, the AX with the VX. And this is going in the I direction. And in the J direction will be AY plus BY in the J direction. And look in this picture, it makes reasonable that this is the vector A plus B. So, what you have to do, I would say that you have to review your textbook. This is part of your textbook. You stop the video and you read a little bit more about the components of the vectors. Stop the video now and come back, and when you come back you will find the next page. The next page will be this one. And this one, you read it. I already said most of the thing. The practice is on conceptual question for vectors. You will see everything on the practice. Solving the conceptual question, you will find this. So stop the video and come back again. Now that you came back, I hope you have read everything, and I hope you are happy with vectors. Very important, make the conceptual questions for vectors.